Welcome to another Tech Stuff Tuesday. This week I'm going to cover something that I've been asked about a lot recently for some reason. I've been asked in the past, but recently it's been a lot, very frequently. I'm going to explain how I select parts for a given build when I'm rebuilding something, particularly when it's something that I didn't make. I didn't design the motor, anything like that. So I'm taking somebody else's product and making it better. So I'm going to tell you exactly how I go about that selection process. Or even if you're just doing a rebuild that you want it something similar, but you don't know what parts to use because those parts aren't available, you don't know part numbers, that kind of thing. So this is our sub that we're going to start with, and this is a very unique scenario that has quite a few challenges, which is perfect for this example because this is basically a worst case scenario. First things first, the basket selection. This is what was originally used on this from the other manufacturer, and we're using it kind of because we have to. These bolts are actually in a very bad position, and this basket actually had to be modified to make this work because they would hit the mounting brackets. But anything with a base that's any wider would have to be cut out, and I don't like cutting baskets. I ground out this one as little as possible. I actually did a little bit less than they did to begin with. So we kind of had to go back this route, but this is a very good basket to use for SPL, and that's what this is being built for. The user, or the owner of these subs, he bought them from the manufacturer as burp-only subs. That's what they're for. They should be built precisely for his car, for his power, and they failed miserably. They were, I guess, not built exactly how he even requested. He said, this is the purpose, bounced back and forth some ideas, and he specifically said, don't do these certain things, and they kind of did them anyway. So here I am rebuilding it, and from that information that he gave me of how it performed with the parts that it had, I can now make a best case judgment call and not do those things that I wouldn't have done to begin with, but I can not do those things and make sure that it's better. So from the frame, we have to make sure we use a cone and spider that work with this frame. There are 3 different landing sizes. We've got to use one of them, and I'm going to use the top landing. And for that, we're going to use this spider. Now, this is a spider that I use very frequently for SPL, like on our YOLOs or something if I'm building something else for SPL. And the reason being, we have got a progressive spider roll on it. And what that means is it's going to tighten up as it gets further in motion. So the more this moves up and down, it's going to tighten up. And that is actually going to help a little bit with controlling the sub from not reaching a mechanical failure, but also it will be better for SPL. If you use a linear spider, they can still work okay, but progressives seem to work better for SPL. That being said, we're also not using a gigantic spider that weighs a lot. This one is an 8-inch spider, so that'll get a fair amount of excursion without having wasted mass like using a 10-inch. These will also tighten down a little bit better, which again is better for SPL. But you don't want to tighten down too much because you can inevitably rip the spider if you have too much X-Max for that spider. So you don't want to use one that's too small, so you cause another problem. This one is a 3-layer, which for this application is going to work out great. I could add spiders to this from this pack if I needed to, but I don't because this is precisely what I need. Even though you're playing maybe something like 60 hertz, it doesn't have to have 8 million spiders on it. You can have 3, and if the box is going to accommodate that, in this case it will, then you want fewer. If the power is going to accommodate, which this will, you would want fewer. And this will actually be louder than just putting a ton of spiders on it and going, well, it's closer to an FS of 60 hertz, so that's going to be louder. That's not necessarily going to be the case. So here's our spider. Had a lot of different options. This is the one we went with. Readily available to me. may not be available to you, and that's where you have to make your own judgment call. But there are reasons we went with this, so that's what we're doing. Our cone. Aspects to consider with the cone. If it's already got the hole cut out to the correct size for your coil, that's a bonus. If it's too big, you can't use it. If it's too small, you can cut it out, but remember, when you cut it out, you're taking away from your cone depth. And that's going to be the next key to this, is does this cone work on this basket? I already know it's got a 3-inch cutout for a 3-inch coil, and the bottom of this cone is going to go right down to where the spider is going across there. So that is a perfect match to have the bottom of the cone at the spider, right where it goes across. This cone fits perfectly. You could have one that's not quite as deep that will come up further, but remember, you're going to have a gap between the spider and the bottom of the cone. And cosmetically, you may not like that. You may want to do something with that. You got to make sure that you have a former that is long enough to do that. And you may also run into issues with your leads depending how you're doing those. So it's not ideal, but can be done. If it's too deep, it would sit up like this. That won't work. You can't just shave it off because that will make your hole larger. So this has got to fit, dimensionally speaking, in the correct spot. The surround is a consideration. This one does have some rigidity to it, which is good for SPL, so you don't have to keep adding spiders. But it will also be made of a material that's not going to tear easily. It's not super flimsy, so that will withhold up to pressure, particularly under movement. Now, the roll on this one is pretty, I think it's as wide as it is tall, and it works pretty well. Some will argue that if you have one that's narrower and taller, that those are actually louder because you have more cone area. It is so minuscule, I don't know that you would ever see it. But how the surround itself moves, the dynamics of that does make a difference, both in SPL and sound quality. So that is a consideration. It's not just the roll, it's the material to be included with that as well. One thing that you can run into with some cones, this one, if you go too far, it'll go right there, and it'll tear if you have too much X-Max for this surround. In this case, that won't happen, but that's something that you should look forward to in playing as. Make sure that your surround can handle the X-Max that you have. That will also go back to your spider, but also your coil length. And that's going to be another thing we're going to talk about here. So the cone, this is going to be what we're using. Also, another consideration is the cone weight and surround weight, as well as the strength. For an SPL application, a lightweight cone can do a lot for you. This one is a little bit heavier than some, but it is extremely strong. You're not going to break this cone. This is the same cone that I've used over 180 decibels. It's not going to break the cone. These are very, very hard to break. So I know it's going to work as application. It's not going to fold, tear, anything like that. But you usually have a little bit heavier cone. Your Kevlar and your carbon fiber and that kind of thing, those can actually weigh just as much as this, even though they are going to be a little bit stronger. But they're usually not too much lighter than this. If they are, they're not exceptionally strong, they can still break or fold or have some type of distortion to them from the movement. So that consideration. For a musical type build, you can have a heavier cone, and you might actually want a heavier cone. That could reflect your FS, may put it down closer to where you want it to be. Or maybe it's a smaller cone and you need the mass just to get the FS down because you're using a little bit stiffer suspension for more power handling. So that's the cone. And then we've got the coil. Now I've got 3 here because there's part to be demonstrated here. Now ideally, this is the coil that I would have liked to have used. The problem is the former isn't long enough. On this sub, this is actually the top plate. Top plate. There is some magnetism here. It's coming across here. It's very low. There are shorting rings down here, and that's to help with inductance. But right here is technically the top plate. So the middle of that coil has got to be at the middle of this. This is 1 inch tall. So we've got to have 1/2 inch on either side of this, and then you're going to have a little bit more. We can't smack the back plate either. That being said, this guy doesn't have a former long enough. I put it in here. We get the middle of the coil down here, and now you can kind of see the former's up here. It won't even get to the spider. So unfortunately, we cannot use this coil based off of former alone. Then you have this one. This would be another candidate. We've got a little bit longer coil on it, so we can fit in here. Nice long former. That should make it. There's only 2 problems. This actually is a little bit shorter. You look at compared to here, it's just a hair shorter, but because of this coil being longer, it's got to sit even lower in the motor. Second problem created from that, we're closer to hitting here. So by the time we max out the spiders and we max out that surround, the bottom of this coil will be dangerously close to smacking right here. I don't feel comfortable with that. I think it could possibly smack even if this form was a little bit longer. So that's another consideration. This one won't work. This one, we have a long enough former. The coil is a good length. We can still get a fair amount of throw. The bottom of the coil will actually be about right here, about full throw. So it is within the gap, so it should cool pretty well. If we had a bunch hanging down from here, the bottom and the very top of that coil at full throw may not actually be cooling very well. In this case, not so much because it's open on top and bottom, so it can vent. But there are cases to consider. If the coil has parts of it that are not being used, they can get very hot because they're not cooling, and then you end up having a failure. So this part of the coil will be cool, the outside would not. The bottom might overheat and burn, or it might slide off, something like that. So we don't want that to happen. So we've got a good coil length, we've got good former length, and this will work out great, even though the cone itself will still end up being about right there when we mount it. So we'll still have a fair amount of glue joint there, whereas the other one, we don't have about that much. And I don't feel good about that holding. That's just going to come up short. So other considerations with selecting the coil beside the obvious on some of those things is we've got the pole OD and the gap, or the top plate, which this isn't really the top plate, ID. The coil has to fit in there. So in your consideration, you have to measure that pole, and obviously the inside of here cannot be smaller. Otherwise the coil just physically won't go on there. Additionally, on the top plate, or in this case the not exactly top plate, it cannot be smaller than this outside diameter because it physically won't fit. So those are 2 things. That's also why coils are not just universal. So we know the gap size, and we know that the coil has to fit within that gap. And this coil does fit within that gap, but maybe it would be too close to the pole to where it's maybe 0.25 millimeters. So this could end up rubbing very easily, or maybe the outside is the same thing. Maybe the outside would end up rubbing, and that's going to cause a big problem. That's going to short out, and it's not going to last. In that case, you would want to try to get this centered in that gap, or if you have to choose one side to go to, you want the inside to be the possible rubbing location instead of the outside. So this would rub the pole, which is not going to immediately short out, where this could rub on it, have scrape marks, and then eventually short it out. But also from a cooling aspect, you're going to get better cooling if you have a little bit more of a gap on the outside than the inside. But the closer you can get to the middle is ideal. Now, another reason why you might have that rubbing, because again, it's supposed to be going perfectly fine, right? Well, if you have a really tight gap, which this one is not going to be, the pole itself is actually narrower than I would have on most subs. So finding a coil to work particularly well in this has been a challenge. And I can't get it exactly where I would want it because it is not a great motor design. So that was causing some challenges. So we're going to do the best that we can do without getting an entire run of coils, because it might be 50 coils that I have to get, and it doesn't make sense when you're building 2 subs. It's very expensive to do. So we're going to do the best we can do with what we have. So why would it rock? Well, we've got the top plate down here. We've got the coil. It's all the way down here with this really long former. So our joint of our spider and our cone is up here. So think of it this way. If you have a slight rock, that's going to be exaggerated down at the bottom. And that slight rock might happen from a change in pressure on the cone as a result of the enclosure, the environment, that kind of thing. Maybe it's just a small amount where the cone is just doing this, just a little bit, but that's very, very exaggerated down here. So that's going to make that rock. Now, ideally, you want this to hit the pole before this hits the outside. Now, the surround can help in this rocking. The spiders are also a factor. But on most cases where this might be the top plate, that triple joint, as we call it, where the spider, cone, and former are all together, if that were down here, this would be less prone to rocking, but also it wouldn't rock as much with the variance. So if it had just a slight rock, it would only be like that instead of up here where it can be like that. So that's a consideration in your sub design. If this is not going to even have the possibility to rock very much, you can use a tighter gap, maybe down to a 0.5 millimeter, something like that. But when you get into really tight gaps, that's not necessarily the best thing, because air still has to move across this coil on the front side and back side for cooling purposes. So for a burp, probably not that big of a deal. But for music, you got to get air across this thing to cool it. So a super tight gap is probably not going to sound very good, because it might be making knocking and pinging, but also it's not going to cool very well. For SPL, they can get you more BL, get you a lower QTS, get your higher SPL. So that case, it's probably going to work better, but that's only assuming that you're not doing musical runs, that kind of thing. When I say SPL, I mean burps. Burst power, short period of time. It's not really going to get hot. You can put 20,000 watts on this, and it's going to warm up very quickly and then cool off very quickly. It's not going to retain that heat. So the way that you should be selecting these parts is going to be very different depending on what kind of build you're doing. For SPL, you kind of want to look at mass, suspension stiffness, compliance, that kind of thing. Musical, you're going to have a focus on FS, how good the spiders sound and how good the surround sounds, because those are factors. But if you are looking at mass, another thing to look at is the coil material. Now, we're using aluminum on this because aluminum is very light. However, you get more BL, more motor strength from using copper. And some will argue that copper also sounds better, but the biggest thing that we're going to focus on here is the end result. So your aluminum coil, if you made the same thing out of copper, the aluminum coil is going to weigh about half as much. But you're going to get about 70% or so of the motor strength. So all things considered, you're not getting double the motor strength for double the weight. Aluminum for SPL is going to be the way to go. Copper generally is not going to be used for SPL. There are certain instances where you could make it work, but generally speaking, that's not how you're going to do it. So we can keep our mass down. We can still have solid strength out of the motor, and our power handling is still going to be pretty good because we've got so much wire here. That's another benefit of copper, is you can get more motor strength out of less material in the grand scheme of things. But again, you're looking at the moving mass as a whole. So now that you've got the basics of all this down on how to make parts fit or which one you should choose, you can get a little bit more in depth and play with these ideas in different builds. So you can take one sub and you can build them with slightly different parts and see the different results that you get. I've built hundreds and hundreds of subs and a lot of engineering, so I kind of know the direction that you should go for a particular goal. So that's where I've got the added benefit of that. But I learned from doing. A lot of stuff looks one way on paper, but in reality comes out different. So I've built so many things. I get the experience from that, and you can do the same thing with any sub that you've already got. If you have any questions or comments about this video, post those below, and I'll try to answer those as quickly and accurately as possible. Make sure you shop emfcaraudio.com for all your sundown audio, EMF audio, audio control, and SBC products. And we are currently having a sale for tax time, so make sure you check out emfcaraudio.com for those deals up to 15% off. You can save hundreds of dollars by buying right now, assuming you're not watching this after March 15th, 2020. You can also support us on Patreon in the link below. Make sure that you are subscribed so you get notifications if you hit that notification bell for all of our new Tech Stuff Tuesday videos and our other uploads as well. This sub will have a video and the complete build and the how-to for it in a future Tech Stuff Tuesday video. And I will see you again in another Tech Stuff Tuesday.